In the late 1990s, I was a graduate student in the lab of Jim Sputich in the Department of Biochemistry at Stanford University. I studied how the motor protein myosin, the molecular motor that powers our muscles and makes our hearts pump, works by swapping parts from myosins of slow and fast organisms, and then testing how those swaps affected its activity. I loved that protein. Understanding how a sequence of amino acids arranged the right way could take energy and turn it into movement by swinging its lever arm a small distance was one of the most interesting questions I could imagine at the time. But when I explained my research to people at parties who asked me, "What do you do?" they would nod and politely smile, then ask when I would graduate. That would be the end of the discussion. That all changed a few months later after I heard a fantastic talk by Dr. Cynthia Kenyon, a professor from the University of California, San Francisco, UCSF. Cynthia is a lively, engaging speaker, and she told the audience about her lab's work on aging and longevity in a small worm, the nematode Caenorhabditis elegans. Her lab had found that changing a single gene could double the lifespan of these animals, and she showed movies of the mutant worms crawling around at an age when normal worms were already decrepit and dying. This was an aha moment that made it clear that she wasn't talking about extending the end of life, but rather the youthful, healthy part of life, an outcome that we would all like to experience. That gene, called DAF2, turned out to encode an insulin IGF-1 receptor, meaning it could matter for people too, since our bodies also have insulin. After hearing her talk, I knew what I wanted to do: find out how those mutant worms were so healthy. Soon after, I asked Cynthia if I could come to her lab for my postdoctoral research, and she agreed. At that point, when people asked me what I was going to do, there was a noticeable difference. It turns out that almost everyone is interested in aging research, and everyone has an opinion about it. It quickly became obvious that one's likelihood of supporting the idea of aging research is generally correlated with one's age, and I got several exhortations to work faster. I decided to write this book after developing a class at Princeton, Molecular Mechanisms of Longevity, the Genetics, Genomics, and Cell Biology of Aging, to teach students about my research field. While preparing for that class, I realized that we, the royal we, being researchers in the field of aging and longevity, have made many molecular insights in the past 2 decades that would be good to convey to the general public.